It's now recording so that others can actually do a follow-up on what we have done. Okay, so we are going to look at encapsulation. In our previous tutorial, we've looked actually on Java basics. We've looked at Java basics. What is Java? Why do we need Java? What are Java variables? Maybe the flow control, the if statements, the for loops, while loops, switch case, all those things we've done them on our previous tutorial. And on this tutorial now, you want to look at the object-oriented programming concepts in Java. Remember, this module is object-oriented programming, and we are using Java as the programming language. So this is the very, very important part of this module. You need to understand what are these object-oriented programming concepts and why do we need them, and also how can you use them in your programs. How can you use them in your programs? Just like that. So the first OOP concept that we are going to look at is the encapsulation in Java. What is this encapsulation in Java? Okay, I need a highlighter. Let me just pick a highlighter here. So I'll try to be quick so that today we are not going to take 2 hours in this tutorial. Okay. So encapsulation in Java, encapsulation is defined as the wrapping up of data under a single unit, which is called a class in Java. So when you're looking at encapsulation, normally you are looking at data binding as well as data hiding. So the process of binding the data under a single unit, which is called a class in Java, it is the mechanism that binds together code and the data it manipulates, right? So encapsulation can be achieved by declaring all the variables in the class as private and writing public methods in the class to set and get the values of variables. So when you're doing encapsulation, it's mainly for you to hide the sensitive data. You want to hide the sensitive data. So how to hide it? Normally, you just need to declare the data members as private members, and then maybe you can have the public accessors and public setters, so that maybe if you want to access them, you can do so through those member methods. So in encapsulation, what are we doing? We are hiding data. We are hiding data. So that's what we call encapsulation. So how do you achieve it? You can achieve it by make sure that the data members are private, and then you can have the public methods as the setters and getters. So this was an example of encapsulation. It is more defined with the setter and getter method, like here where you are having the data members, private string name, and then private int age. If you look at that one, you have made those two variables private. Those are the data members that you're talking about. And then after that, you are going to have the get name, the set name. So those are the setters and the getters methods that we are that we are talking about. And if you look at them for get method, if you look at it, it's what? It's a public method. And if you look at it, it's going to return the name. It's going to return the name, something like that. So it is going to return a string. So for getter methods, it's obvious that they need to return something. So these are public methods, and they will be return something. That something is the actual data member here that you're talking about. So it needs to return the data member. And then for setter method, it's a void method, and it will be taking a parameter here. It will be having a parameter so that you can pass and set the name, right? So it's not going to return anything, but it must take a parameter. For getter methods, there will be no parameters here. There will be no parameters here. So that's encapsulation. Maybe I can have another resource here to quickly explain. If you go on W3 schools, there's good there are good notes there for encapsulation. Here, encapsulation is to make sure that sensitive data is hidden from users. To achieve this, you must declare the class variables or attributes as private and provide public get and set methods to access and update the value of a private variable. So maybe I'm just going to have a quick example on this one. I'm just going to have a quick example on this one. Maybe I can have a new project. Let me just okay, let me just use the one that we were using last time, which was demo. Here, I'm sure everyone now can create. It's this one. It's not this one, but it's still we can make use of this. Allow me to take out all these classes. Yeah, sure, we are good to go. Okay, so when you are talking about encapsulation, we are saying we can have maybe in here data members, and these data members you have to mark them private. Okay, so I can have maybe something like private string name, and then maybe I can have private maybe int age, right? And then I need to provide a getter and setter method for these data members because they are private. So there's no any class that can make use of these variables, right? I'm sure you've done the access modifiers and we have explained on this issue. If something's private, no one is going to be able to use it. Even through inheritance, you are not able to use it. So for other classes to be able to use that one, you need to have the getters and setters method. So normally for setters method, and they must be public so that they can be accessed by other classes. So here I can say public because it's a setter method, it will not return anything. So it's void. And then because I want to set the name, I have to say set name, right? So it starts with the keyword set for a setter method. Then for getter methods, you say get. So it's set name. And then because I want to set the name, I need to pass a string variable here, which is a parameter here. Maybe I can just say new name, just like that. You can give it any name that you want to give it there. So I can say this dot name. I've explained on this one on our previous tutorial. What does this mean? This keyword, right? So here I can put a new name here, right? Uh, so what it means is that whenever I call this method, it means that I can pass, it means I can pass the name here, and then the name will be set to this object. And then after this, I can also have, uh, here's public. Oh, let me just have a special class for these guys. So let me just have a class. Let me just call it person, right? And then let me just have a special class for doing this. There's a reason why I'm doing so, because I want to demonstrate. Otherwise, suppose this will be in the same class, so it will be not making any sense at all. So if I put them here, and then you have these methods also here, and then we'll be using the class test to actually test our code. All right, to run our code. Okay. So after that, I would want to put the getter name for us to be able to get the name. So for that, you need to make sure that it's a public method. And after that, you also need to make sure that it will return a string because the name is of a string type. And then we say get name. And then here we are not going to pass anything, but this method must be always return what? It must return name. So we can say return this dot name just like that. Can even say return name just like that. It will just pick that one, right? It will just pick that one. There's no difference with that. Maybe here, if I say this variable, all right, if I say this one is going to be like this, That's where you need this keyword. Why? Because we need to differentiate the local variable and the instance variable here. So here you must use this keyword whenever you have the local variable and the instance variable and you want to reference the instance variable. So you need to use this keyword so that you'll be referring to this to this variable, just like that. So here after this, what am I supposed to do? Also, I need a method to get the edge as well as to set the edge. So I can have what I can have here is public, right? Because I want to set, it must be a void because I'm not going to turn anything. And then this one is set what? Edge, right? And then because I want to set, I need to take a parameter here, which is int, and then maybe I can say edge. Because I have a local variable named edge, I have to use this to refer to the variable that I want to set, which is edge be equal to the local variable edge, which means I'm going to take this value that we are going to send to this method, and then I'll put it into this uh, uh, data member, which is the edge. And then after I be able to set, we can now also get the edge. It needs to be public. That's the first rule of the game. After making it public, then what are you supposed to do? You need to make sure that it returns an integer because the edge is what is integer. And then you put get keyword, and then you put the variable name get edge, just like that. And then use the camel case, start this with a small letter G, and then for inner words you put capital letters. And then because it returns an integer, it must return an integer as well, but the integer is what? Is edge. So you can just write edge or this dot edge. There's no problem with that, but you can just write edge. It will just pick this instance variable. So if you're looking at this, we've got a class called person. So without all these methods, it's obvious that we cannot use all these methods in any class, right? So we've secured our code. We've made sure that no one is going to be able to access this. And then maybe if there is a case that we can expose this, or we can have people be able to access these variables, they can only do so through these accessor and setter methods that will be put in that class. So that's what you call an encapsulation there. So maybe I can come here and have an object of class person, maybe person P1. Let me just say it's equals to new person, right? This is the object of class person. And then I want to set the name. Remember, there's nothing here. Let me just try to print the name. This out. Let me just try to print the name so that you could see what I'm talking about. Let me just say here P1 dot name, right? Oh, I cannot access the name exactly, so I can just say get name, right? So it means that this one is supposed to return the name and then print the name. If I do so, I'm going to get a now. Why? Because I didn't put any name here. So I need to set the name for P1 and then I'll print it, right? So let me just set the name. I will say P1 dot set. Let me just set name and then let me just put my name there. Okay. After doing this, if I run this, you see that we're going to get the name for what? For P1. But if you look at that, if I try to get the name directly, I cannot do that, right? If I try to get the name directly, I cannot do that. If I say P1 dot name, I cannot do that. Why? Because name is not visible, right? For it to be visible, I need to mark it public or something. We have done access modifiers, maybe default access or protected, something like that. But here, I'm just going to use what? The public setter methods and the getter method. Here I've set the name, and here I'm now getting what? The value of that name. I can do the same with what? With edge, right? I can also get what? Edge if I say get age, but remember, maybe let me just say here, you know, so that it will be maybe something like this age. But remember, I didn't set age, so for age it is going to be 0 because I didn't put age there. So I can do the same here. Let me just say, yeah, just say name, yeah. So I need also to set the age for P1, so I can say P1 dot set age, and then I'll pass the age. Let me just put 20 there. If I run that, what do I get? You see, I'm going to get. So the concept here is for you to be able to actually access these, but but they must be private. All right, so you need to make the data members private so that you hide them, you secure them from the outside world, and then you provide the setter methods and the getter method to access and modify them. And these public methods for each and every data member, you'll be able to actually manipulate through the either getter or the setter method, right? Just like that. So maybe we need to look at the next object-oriented programming concept, which is not this one. I don't know if I've got questions on encapsulation. I don't know if I've got questions in encapsulation. So that's encapsulation in Java. That's the encapsulation in Java.
Sorry, sir.
Yes.
Sorry to interrupt. What's the main purpose of hiding data? Like I can see we can just access data using the public method. Why do we need to use the getter and setter method? What's the real?
Okay, the real deal on this one is that you have a better control of accessibility. If you decide not to actually have someone be able to actually manipulate the values within your project, you could make sure that the variables there are just read only, which means you provide only the setter method without a getter method. You can also give the right ability to write to your variables through the setter method. So through the setter method, right? Just like that. So you will be having that ability to control who is going to read, who is going to write. So for the case where you just need people to be able to just read from it but not manipulate it, then you give them the getters only without the setters. So that's the main purpose of this one. So it also for better control of class attributes and the methods. Who is going to access this? Who is not to be able to access this? Which methods that which data members do I think that people do not need to be able to manipulate, but only just to read, right? So that's what we are doing there. That's what we are doing. If you look at this one here, we are saying we've got increased security of data. So it's not good for you to just declare everything public when you're declaring your objects, or not all your objects, but your data members. Do not always mark them public. Mark those that you want to be public. So maybe in a case where you want some of the variables to be editable or to be only accessed through reading, but not to be able to be changed their values, then you'll be make sure that you behave in the getter methods, but no setter methods, something like that. So that's the purpose of encapsulation. I'm sure you are answered on this one.
Thank you, sir. Could you do us a favor and give us an example? It can enlighten to us why we should do this.
Okay.
If you can.
Okay, it's okay, no problem. If you look at this one, the example if you already have it. Let me just take out this setter method. Let me just take out this setter method for set name, and then I'm just going to put a default value here in the name, right? And then I'm just going to say It means that whoever who want to use this variable can only read from it, but you cannot actually manipulate or change the value within it. Why? Because if you look at it, if I come here and try to access try to manipulate or change the name, it's obvious that I will try to do it with the name, but the name is not what? Is not public, it's not available. I cannot access it. So I can only access this name through the getter method, but there is no setter method for that. It means that I cannot set it. So for that scenario, if you have such data members within your projects that you think that people just need to read from them, but not be able to alter them, then you can make sure that you do not provide the setter methods for such variables. So that's it on encapsulation. I hope you are answered on that one.
Yeah, thank you. I got it.
Okay, so let's look at inheritance. Yeah, let's look at inheritance, and then later on we look at polymorphism. So normally inheritance is where you have or is when you have a class being built on top of another class. You already have a class, and then you inherit from that class instead of starting from zero. You are just creating another class basing on another class. So inheritance is an important pillar of object-oriented programming concepts. It is the mechanism in Java by which one class is allowed to inherit the features or fields or methods of another class. So in Java, inheritance means creating new classes based on what? On existing ones. That's all on OOP. So in other words, we are promoting code reuse or the code reusability instead of starting from zero. Maybe you've written this method somewhere in another class. Instead of repeating it, you can just import it and use it, just like that. So that's what we are saying with this OOP concept. Inheritance, just need to import, maybe you just need to inherit from another class. If the method already exists, or if these data members already exist, just inherit them. Why declare them? Why creating new methods as if they are not there? If they are there, just inherit them and just use them. That's what we are talking about when it comes to inheritance. So why do we need inheritance? The key feature of OOP, allowing you to create flexible and reusable code. Understanding how to implement it effectively can greatly improve the structure of your programs. So the main issue there is what? Code reusability. The code written in the superclass is common to all subclasses, so child class can directly use the parent class code. Maybe also there's this concept of method overriding, which you're going to talk about when you're doing polymorphism. It's very, very important. Again, you can do method overriding through inheritance. You inherit and then you override. We call it's polymorphism. It's polymorphism. We're going to talk about it when you're doing polymorphism, but you can achieve that also through inheritance. So it's achievable only through inheritance. It is one of the ways by which Java achieves runtime polymorphism. So you see that inheritance is important. So also there is abstraction there, the concept of abstract, where we do not have to provide all details. This one we're going to talk about when you do abstraction. We are going to do abstraction. This is also a concept on its own. You're going to talk about it on its own. So important technologies used in Java inheritance. There are basics on inheritance, or some of the keywords that you need to know on inheritance. So the class itself, I'm sure you know what is a class in Java. We've been talking about this. So class is a set of objects which shares common characteristics or behaviors and common properties or attributes. So class is not a real-world entity. It is just a template or a blueprint or a prototype from which objects are created. Then there's what we call a superclass or a parent class. So the class whose features are inherited is known as a superclass or as a superclass. So that class that we are inheriting from is the one that we call the superclass. And then the subclass is just the class that inherits the other classes. So those ones are the ones that we call the subclass or just child class, right? So you have a superclass and subclass, or a parent class and a child class. Then there's issue of reusability. If you're talking of reusability in inheritance, is that when we want to create a new class and there's already a class that includes some of the code that we want, we can drive our new class from the existing class. So by doing this, we are reusing the fields as well as the methods of the existing class. So that's why we do inheritance. And then you need to know that when you do, we can achieve inheritance through the use of extends keyword. So the extends keyword is used for inheritance in Java. Using the extends keyword indicates you are derived from an existing class. So in other words, extends refers to increased functionality. So guys, maybe you just need also to understand what is going to be inherited and what is not going to be inherited. So you need to know that which one is going to be inherited and which one is not going to be to be inherited. So maybe what I can do is to have in this basic example that we're doing here, why not having, maybe I've already this class person. Let me just think of a better example that we can use here. Okay, let me just make this one what? It was what? Person. Let me just mark it a student. Right, let me just mark it a student. And then it means that here I'm being forced to change this one to student as well. All right, student, right? So in this class, you're going to have these data members. All right, let me just take this one out. Okay, let me take this one out. And then, because if they are private, I'm not gonna be able to to inherit them. Let me just make them public so that I'll be able to let me take all this out. All right. So maybe what I want to do is this class called is student. You know that a student have got a name, right? A student have got a name. Maybe we can have also a method. You can also have a method, maybe here public, or I can just mark it void register. A student can also do register as well. Maybe what you're going to do is I'm just going to print out that maybe registered modules, maybe or register modules. Let me just say register modules, right? All right. So this is class with this method to register modules, and then I'll just say register module. I'm not going to do anything there. And then after this, I'm just going to have another class here. Let me just have another class called person. Let me just have a class called person. Let me just have a class called person. It might be a weird example, but let me just do that. I'm just on this class. What I'm going to do is so this class needs to extends, right? Let it extends. Use the extends keyword, which means we are inheriting. So I'm just going to extend the class what? Student. I'm just going to extend the class student. So guys, whenever I've extended this class called what? Called student, right? And there's nothing in this class called person, right? But I can safely say that by now this class called person have got a name, have got an age, also have got this method to register. But I didn't write anything in there. If I come here, let me just come here and try to print. I want to print the registered modules. So what I'm going to do is I'm going to have an object of this class person, right? And what I'm going to do here is going to create an object of class person P1. Let's go to new person. And then, sorry, I forgot to terminate here. And then I'm just going to say P1 dot, I'm going to call register method. If you look at it, this class called person, this class called person, this one class called person, there's no method within this class. It's not visible, you are not seeing it, but it's already there. Why? Because I'm extending or I'm inheriting from the class student. It means that all the methods, if I run this, you are seeing these registered modules. All the methods which are inheritable in this class, they are also available in this in this class. It means even here, I can just assign a name. It's only that I can try to assign name to this. Let me try this. Why am I getting an error? Okay. I'm not in a method. And this is where you declare what instance variables. I was supposed to be in a method to try to access these ones. But what I'm saying is, if you try to look at this register method, we have actually inherited it. So I can try to see which access modifiers can you apply if you want to make sure that these data members or data methods or member methods are available for inheritance. If I mark this one protected, what is going to happen with this one? I'm still able to use it, and if I run, you see that I can still inherit if it is protected. What if it is default? We have seen that, right? What if it is private? If you mark it private and save, here I'm going to have a problem. I cannot inherit members which are private. So if you want to inherit something, make sure that you make it what? You make it either default, you can make it protected, or you can make it what? Public. And then now you need to understand the access modifiers. We have done this one before on access modifiers. You know that if it is protected, it's on the package level. What it means if it is default access modifier, you need to understand all those things. But here, if you want to make sure that your thing is inheritable, make sure that it's public, protected, or the default access modifier. If you mark it private, you are not going to be able to use it. So that's what it is with inheritance. If you look at it, I didn't create this method. It's already there, so I just inherited and just used it. I just inherited and actually used that, just like that. So it's just the same. If I try to access P1 dot name, I can do so and assign the name there using this object, just like that. Easy peasy, just like that. If you look at that, I'm just able to inherit it, but here I didn't declare anything, but I'm able to actually inherit all these data members and able to what? To manipulate them, to use them just like that. So you can just think of yourself having a program, maybe with a method with 200 lines of code, or maybe 100 lines of code, or maybe 50 lines of code. Instead of just keep on writing that method, you can just inherit it and use that, just like that. So that's what it is with inheritance. I don't know if I've got some questions on this one. Maybe want to ask questions, or maybe want to say something on this one, maybe to contribute. Feel free. Yes, feel free. You can just raise your hand. So that's it with inheritance. Maybe you can look at polymorphism. You can look at polymorphism. What is polymorphism? Maybe why do we need polymorphism, and what are the types of polymorphism, and how can you achieve polymorphism in Java? So for inheritance, you just need the extends keyword, and then you just need to make sure that are your data members that you need to inherit, are they inheritable? by ensuring that the access modifiers you can inherit by you can set them to be inheritable by setting those specific access modifiers. You can do the same for the methods as well. So let's look at polymorphism. So the word polymorphism means having many forms. So in simple words, we can define Java polymorphism as the ability of a message to be displayed in more than one form. So we can have maybe one specific method being displayed in many forms. So a real life illustration of polymorphism in Java is a person can have different characteristics at the same time. So like a man at the same time is a father, also a husband and an employee. So the same person possesses different behaviors in different situations. So this is what we call polymorphism. So what is it in Java? So polymorphism is considered one of the important features of object-oriented programming. Polymorphism allows us to perform a single action in different ways. So we can have maybe one method with the different implementations. So that's what we call polymorphism. So in other words, polymorphism allows you to define one interface and have multiple implementations, which means the word poly means many as well as morphs means forms. So it just means many forms. So what are the types of polymorphism in Java? So in Java, polymorphism is mainly divided into two types. What are these types? There's what we call compile time polymorphism and runtime polymorphism. You just need to know the difference of this. What is compile time polymorphism and what is runtime polymorphism? What differs these two things? So the compile time polymorphism in Java, it is also known as the static polymorphism. This type of polymorphism is achieved by function overloading or operator overloading. This one, we know that at the compile time, we know which method is going to be called whenever you create the object of that class. That's why we call it compile time polymorphism. Remember on polymorphism, I say we have got one method doing different things at a given moment, right? So just imagine when you're calling a method, which one is going to run, right? So at compile time, you are saying, we know that this method is going to run. That's what we are called. Well, that's what we are calling compile time polymorphism. So in that case, where you know that at compile time, this method is going to run out of all the implementation that we have, this method is going to run. Then we know that this is compile time polymorphism. Otherwise, you know it at runtime during the execution, right? So after just compiling, you know that this one. So the compile time polymorphism can be actually done through what we call method overloading. So what is method overloading? This is an example of method overloading. You can have one method called funny, but with a lot of what? With a lot of or with a different number of parameters. So you're overloading the method just the same, right? Void, fun, then the number of parameters will be the one which will be differentiating the method. So at compile time, we know that if you call a method with one parameter, we know which exact method are you trying to invoke, and then we invoke that. So we know it at compile time, right? So method overloading where there are multiple functions with the same name but different parameters, then these functions are said to be overloaded. So function can be overloaded by changes in the number of arguments or and change in the types of arguments. So maybe you can have a simple example here which shows compile time polymorphism. What can I do here? Maybe best thing, let me take all these things out. Let's ignore this, or let's just take all this out. I don't think we need it anymore. Don't think we need it anymore. So in this class test, guys, very, very simple. I can have different types of methods. Let me just have maybe a method to add maybe 2 numbers, to add 3 numbers, to add 4 numbers, something like that. Just as simple as that. And then after that, maybe we return the result. Yeah, it will be not complex. All right, so let me just save it. You can mark it public, no problem, private, whatever. because we are not going to test the access modifier. So let me just say int add, right? It is going to return something. So you want to add, right? What do you want to add? Maybe you want to add int, sorry, you want to add int a and int b, right? After that, I'm supposed to return, what am I supposed to return? I'm supposed to return a plus b. I need to return the addition of a and b. So it's just saying this is a method to add two numbers. This is a method to add two numbers. Here there's no method overloading at all. But if I want to include the method overloading, let me now have int add, and then here I need to pass, maybe I can say int a, int b. Then if you do this, I'm going to have an error. Why? Because we have got same number of parameters and same number of, so they are identical. They are identical. So I need to put another, maybe int c, right? And then after that, I need to return a plus b plus c, right? So it means I'm going to add these three numbers, then I'll tell. If you look at that, this is just the same method, add method. But now it have got different implementations, right? This one is only to add two numbers. And this one is only to add three numbers, right? I can do so by adding maybe another method again, and then I can add here to have int d, right? So guys, also the other thing, if you try to do this, I want to show you something here. If I try to do this and try to change here, put maybe C, maybe saying that this method is different from this one, they're just the same. They're taking two integer parameters, and then also it is returning an integer, and then there's the same name. So these are just same method. Don't try it. If you want it to be different, maybe you can put here maybe a string whenever there are different types of parameters, then it means those methods, they are different. Because why? Because when you are calling, you're going to pass a string and then an integer. That's what I want to show you on this one. So this is how you can do method overloading. Maybe I can have test team, go to new test. I'm creating an object of class test. And then what else? From here, what I can do, okay, I can add numbers and then print results. Yeah. Let me just this out. Was okay. All right. What I can do, not this one. Okay, let me just say result. I like it this way. All right. So what I'm going to do is I want to add two numbers. So I'm going to say t dot add, and there are all three methods there. If you look at them, they're just the same. It's just an add method. So that's the polymorphism. It means many forms. It's just one method, but in many forms. If you are looking at it, I can actually add. If you are looking at it, I can actually add either two numbers or maybe three numbers, or four numbers, just like that. So I'm going to add just two numbers. I'm going to add a 2, maybe, in the 100. What am I going to get as the result? The result is 102, just like that. So maybe I can do add again, but here now I want to add three numbers, right? You see how easy it is. So here, so if you are looking at it, we are just using, it's one method, but in three forms. It's one method, but in three forms. This is what you call compile time polymorphism. why compile time polymorphism and not runtime polymorphism? If you are looking at it during coding, I know the exact method that I want to run. I'm actually calling the method with the two what? Are you seeing it? With the two parameters, which means it's this one which is going to be called. And I'm sure that this is the method which is going to be called. So at compile time, I know. But if it is a runtime environment, if it is runtime polymorphism, you do not know it. You just know it during execution. So that's what it is. That's what it is. For compile time versus so for compile time polymorphism, you can do it through method overloading. What if it is runtime polymorphism? You can only do it through inheritance. We've done inheritance shortly. We've done inheritance. So now let's look at the issue of runtime in runtime polymorphism. So this is how you do. You can do it through function overloading for compile time polymorphism. Now let's look at runtime polymorphism. It is also known as dynamic method dispatch. It is a process in which a function called to the overridden method is resolved at runtime. So this type of polymorphism is achieved by method overriding. So method overriding, on the other hand, occurs when a derived class has definition for one of the member functions of the base class. So that base class, that base function is to be overridden. So, like for example, here, if you look at it, we've got this parent, class parent, and then we've got print, right? And then you've got the subclass one, which extends parent. Also, we've got a method to print, which means we are overriding this method, right? And then we've got the subclass 2, which is also doing that. If you look at it, you're going to have the parent class. And then from the parent class, you can create the object of subclass 1. And then from there, you can call print. And then you can call print to see which method is going to be invoked. Maybe you can try this one as well. Let's try it to see this one. So for this one, I need inheritance. So let me just take out this. It no need of this. Let me just take. So for me to be able to do inheritance, all right. All right. Maybe I can have another class called parent. Oh, sorry. For a class, we do not need that. So in this class called the parent, what can I put? All right, let me just put void print, right? Inside the void print, I'm just going to say this out. And then I'll just say parent class. And then from this, I'm just going to have another class, which is subclass class sub1. Let me just name it sub1 to save time. Then I use extends to do inheritance, extends parent, and then I'll do this. You know, the void print is already there within this class, but we can override it as well. And then during runtime, then the method to be executed will be chosen during runtime. That's what we are talking about. So here I can put this one, right? So if you look at this, we have override, or we have overridden this method. Normally they'll put it override at the top. Let me try to put it at override. So I can put that on as well. And I put it. Yes, it's an annotation at override. Give me what you are supposed to be. No need of it to be there, but if you generate them, it will just put an annotation and gets it over or it override. Sys out. Right, let me do this. And then I'm just going to print that subclass 1. So I'm going to print sub1. So I can do this, guys. If you're a programmer, be good at cutting and paste as well as copying and paste. to save time, I'm going to have this, but this one I'm going to mark it subclass 2, and I'm going to have subclass 2. So what I'm going to do, guys, I'm just going to have a create. I'm just going to create an object of parent class, right? And I'm going to say parent A, and then I'm going to have a new object of class what? And then I'll just call this void, right? This void. Yeah, all right. So let me just have a new sub1, right? So I've created an object of subclass 1, and then if I say a dot print, what am I going to get at runtime? I got sub1. I got sub1 at runtime. What else? What else? What are other tests that we can do? You can also do the same for A, for new subclass 2. You are creating an object of subclass 2. Obviously, the reference that we are using is the same reference, the one of the parent class. And then I can say here, okay, we've got the print method. So I can do this. You are going to see sub1 here, and then here you are going to see sub2. So guys, let's just have a look on this one. If you look at it, this is the object of the parent class. But after that, I'm assigning the reference, this reference to a sub1 object, which means subclass 1 object. So it's as good as I'm creating a subclass 1 object. And when I'm calling that, we are deciding at runtime that which method are we going to run either in the parent class or in the subclass. So that's why we call it runtime polymorphism. So that's the difference with the compare time polymorphism. So you need to know how to achieve runtime polymorphism and compare time polymorphism. Runtime, you can do it through inheritance, and then compare time, you can do it through method overloading. Here, you just need to do it through inheritance and the method overriding for compare, for runtime polymorphism. So that's it on polymorphism. For overriding a method, guys, you need to make sure that everything just the same. Start from the returning type, the name of it, also the access modifier. If you mark it public here, it's no longer the same as this one. If you mark it private here, it's no longer the same. So for overriding, it needs to be just the same, right? So that's it on polymorphism. I don't know if I've got questions. I don't know if I've got questions. I don't know if I've got questions. So these are some of the advantages of polymorphism: increase code reusability by allowing objects of different classes to be treated as objects of a common class, improves readability and maintainability of code, supports dynamic binding, enabling the correct method to be called at runtime based on the actual class of the object, enables objects to be treated as a single type as well, though it is kind of difficult and complex to implement. So normally that's what we need from polymorphism. So I don't know if I've got questions on this one. We need to look at abstraction, and that's the last thing that we are going to look at for this tutorial. Maybe I'll just do a quick example if I need to do that. So on abstraction in Java is the process in which we can only show essential details or functionality to the user. So the non-essential implementation details are not displayed to the user. So what is abstraction in Java? In Java, abstraction is achieved by interfaces and abstract classes. So for us, we're going to just to use abstract classes, but we can achieve 100% abstraction through the use of interfaces. It's very, very simple to code interfaces. You can also go and look on that on interfaces. What are interfaces in Java? How can you use interfaces? They're just like a class, but they are not a class. So there are differences between classes and interface. You can look at that as well. So I'm just going to use abstract classes to do abstraction. So that abstraction may also be defined as the process of identifying only the required characteristics of an object, ignoring the irrelevant details. So the properties and behaviors of an object differentiate it from other objects of similar type and also help in classifying or grouping the object. So on data abstraction, you are just showing things that you want the user to see, and you hide the rest. So you hide the implementation, just expose that this application is going to do this, whatever, but you hide the implementation, just hide the implementation. Only make it available when you want it. So Java abstract classes, you need to understand what are the Java abstract classes, how to code them. I'm sure this one was also part of your assignment one. So an abstract class is a class that is declared with an abstract keyword. An abstract method is a method that is declared with without implementation. So whenever I want to have an abstract method, you need to make sure that it doesn't have the block code of the implementation. And if it doesn't have that, then it will become an abstract method. And you need to mark it with the keyword abstract. Also, an abstract class may or may not have all abstract methods. Some of them can be concrete methods. So in other words, you can have a class which have got abstract methods, but it doesn't make it, or it doesn't force it to only have abstract methods. So it can have a mixture of both abstract and non-abstract methods. And then an abstract method must always be redefined in the subclass. So if you are inheriting from an abstract class, it means that you need to make sure that you actually redefine or you override the abstract method. Failure to do so, that class must be also an abstract. If a failure to do that, the subclass itself will become the abstract. So any class that contains one or more abstract methods must also be declared with a keyword what abstract. So there can be no object of an abstract class here. You need to know that you cannot also create an object of a what? Of an abstract class. So an abstract class can have parameterized constructors, and the default constructor is always present, in that case, whatever. So maybe you can go and read on when to use these abstract classes and abstract methods. So if there are situations in which we want to define a superclass that declares the structure of a given abstraction without providing a complete implementation of every method. So sometimes you want to create a superclass that only defines a generalization form that will be shared by all its subclasses, leaving to each subclass to fill in the details. So whenever you have such scenario, you want to hide some of things before actually exposing them within the subclasses. So you can do that through what? Through abstraction. You can do that through what? Through abstraction. So this was an example of abstraction where you have a class called shape, and then if you look at it, it have got an abstract double area here, and then it have got other methods like this to string. It's an abstract method, but if you look at it also, it have got other methods like the shape. This one is a constructor, and after that the string get color of the shape. This one is an implemented method, but this one is the abstract. These are the abstract methods. So if you look at this class shape, it have left the issue of area to be an abstract method, which means that each and every uh, shape which is going to inherit from this class needs to define its own means of finding the area. So in such scenarios, you can do abstraction. You are not showing how to calculate an area of a shape, but you are showing that how to print the color of that shape, right? Just as simple as that. Let's make sure that we are always on mute. Let's make sure that we are always on mute. Let's make sure that we're always on mute. I don't know to make anybody perfect. Okay. So on abstraction, maybe I can just have a quick example on abstraction. Let me just have an abstract class. Let me take out all these classes. All right. What can I do here? Right, I need to take out these ones as well. All right, let me just have a symbol. A symbol class here. If I mark a class like the one shape, let me just have a class shape. I want it to see something. And if I have an abstract method, right? And then I'll mark it area. Oh, so this one should be what? Was it returning the area? Was it an int area? Okay, double area. It was supposed to return a double area. All right. Double area, just like this. If you look at this, what's the error here? The abstract method area is in type shape can only be defined by an abstract class. What it means that if you are going to have an abstract method within a class, you need to make sure that the class is also what? Abstract. As simple as that. The class is also abstract. By doing so, you've solved all your errors there. Right? And then you can also have other methods within this class, right? Maybe I can have what is this? There was the issue of color, the color of a shape. Maybe I can say string color. And then what else? Yes, the color of a shape. And then from there, maybe what was that? All right, here I can have what can I have? I can have a method to calculate what? Okay, let me just print the color. Let me just print the color of a what? System, not system. I can have a method, all right. I can have a method to print the color, right? So this method, let me just mark it as public. Let me just make it public. Void, it should be a void method. Print color. Yes, I'm just going to print the color. And then, am I going to print that? Am I going to really print that the color? Is this necessary? Well, let me just see this out. Yes, let me just print color. Let me just put red there, and let me just put. Okay, so I need the get. I need to set and get. Maybe I need string color. Sorry, not a string color. I just need to put string there to meaning that it's going to turn a string. And then here, not print color as such. What can I make it of instead of print color? Let me have a set color, right? Right, let me just have set color, and then what I'm going to do is just going to set the color. Here it is supposed to get a string again. All right. Column, this is going to add. And if it is a setter method again, it's not going to return anything. Let it be a void. This dot column is equal to color, which is local variable, right? So I'm going to have the setter method as well. Let me just have a setter method. Yes, then this one is going to return string. I can manipulate these things later. All right. And then it's not going to take anything. It's a what? It's a getter method. Yes, it's not going to take anything. And then here it's supposed to be get color, and then it will return this color, return All right. So I've got this class, and if you look at it, it's an abstract class. Why? Because it have got an abstract method, right? So that's why it is an abstract class. Then if I'm going to have a class which is going to inherit from this class, if it is not going to implement this, so it's going to be an abstract class as well. So I can have another class maybe called rectangle. Let me just have another class called rectangle. Right, this class called rectangle is going to what? Let me just put. It's going to extend. It's going to extend. Means extends shape. So I'm inheriting from the class shape, but have a look at this, saying that the type rectangle must implement the inherited abstract methods from the what? From the shape class, and that method is shape dot area, which means that method is area. So it is saying that if I'm not going to actually implement this method, it means that this class must be also an abstract class. But remember, I do not want this class to be abstract. I also want it to be, so just add an implemented methods. It means that it will override that method, and it will give me this method called what? Double area, this one, which is this method that I have, this double area. So after doing this, now I need to do the implementation of this area. And you know that for me to calculate the area of this shape, I need to have maybe length and the what? And the width. So of course, here we didn't put these things that you wanted. Let me just return maybe length times width, and I'm just going to declare the variables here. Int L maybe is equal to 10. I'm not going to pass anything. Otherwise, for it to be real, I'm supposed to put maybe what I'm going to accept here. So length and width of 10, just like that. And I'm going to return L times length times width, and something like this. Yes, that's what I'm going to do. So if I come here in this class and have if I'm going to have the class rectangle, the object of class rectangle here, I'm going to have the object of class rectangle, ri is equal to new rectangle. All right, it means I can create the object of this class. Why? Because this class is not an abstract class, and then I can have r. Let me just print this one out. Is out. Then I can print out that area. What is the area? All right. What if I can say r dot area? So it can give me the area. If I run this, it can give me the area. So if you look at it in the class shape, I do not have the implementation of this method. So anyone to access this abstract class cannot get the detail of this implementation. I've only added the implementation here in this class rectangle, but the method was already there in this class, right? But there is no implementation. So that's it on abstraction. That's it on abstraction. So just need to know how to do it how to do abstraction, how to use abstraction, what is abstraction in Java. So you need to know that, and why do you need abstraction in Java? So you can call these setter methods, getter methods on color. Why? Because they are public, and we are inheriting the class shape. So I think I've demonstrated, guys, that if you are not going to implement this method, you are going to have an error which says that a compare time error which says that this class must be abstract. Why? Because it didn't implement this abstract method. So the concept is very, very basic. A class with an abstract method is also an abstract class. So if you do not override this, it means you have got a what? You have got this method here because we're trying to inherit, but only that but inherit. So this class will be forced to be what? An abstract class. So that's it on abstraction. I don't know if I've got questions before. Maybe I do an example of the question which was on your assignment one, which was needing abstraction, maybe inheritance. Yeah, there was a combination of abstraction and inheritance. I'm doing so because I believe that everyone would have submitted their assignments one. So that's why I'm doing so. Maybe we can just do it as a revision, and then you can do all these alone. So you can use also interface. You can go and look on that. How can you use interface to do that? So these are some of the advantages of using what? Of using abstraction. You can go and read on this. There are a lot of advantages of using abstraction. Remember that you are using abstraction through inheritance as well, which means that the advantages of inheritance are also part of the advantages of what? Of abstraction. So I don't know if I've got questions on abstraction. I don't know if I've got questions on abstraction. Okay, so if there are no questions, let's look at this one. I'm just trying to demonstrate to you how can you use Java to actually how can you use Java to actually answer these questions if you're given these questions. Also, guys, make sure that you go on to read threads. You go on to read threads, guys. Go and read on threads in Java. What else? Okay, go and read on threads on Java as well. Also, go and read garbage collection. If there are no learning materials, please ask me in the group. Or you can just find one yourself online. Yeah, you can find one for yourself online. So let's look at this question. Where is it? Okay, this question, which was question number 4, which was, so if you are being asked, guys, for this question, explain what is meant by the following terms in object programming. You need to be able to explain polymorphism inheritance, what is encapsulation, what is abstraction. You must be able to explain all this. Okay, so let's look at this question. We are saying create a superclass called the student and the 2 subclasses called undergrad and grad, right? So guys, when you're being asked such questions, you need to take note of these things. You see the length of this question. It's like a paragraph. So if you do not take notes on this, you are going to miss some of the things, right? So now, by now, we know that we are going to need a 1 superclass or the parent class and 2 subclasses. And the name of the superclass is student, and these subclasses are undergrad and grad. And after that, you need to know that in the superclass, student should have the following data members. In the superclass, you are going to have data members, which are name, ID, grade, age, as well as address, right? So the superclass student should have at least 1 method. So in the student class, you're going to have the method called is passed, and it must be a Boolean. The purpose of the is passed method is to take 1 parameter, which is what grade. So you need to take note of these guys. And the value you are supposed to take is between 0 and 100. And check whether the grade has passed the requirement for passing a course. So in the student class, this method should be empty as an abstract method. So guys, you are being told that in the student class, this method should be an abstract method, which means it tells you also that the student class must be also an abstract class. And then the 2 subclasses, grad and undergrad, we inherit all data members of the student class and override the method is passed. So guys, here you are being told that the data members here, name, ID, blah, blah, what, they must be inheritable, which means we must mark them public or mark them default, but make sure that they are what? They are inheritable. And then in those class, you must also override, which means you need to implement the is passed method. For the undergrad, you are being told that the class of if the grade is above 70, then is passed returns true. Otherwise, it returns false. Then for grad class, if the grade is above 80, then it's passed, it returns true. Otherwise, it returns false. So if you look at it, now it's a paragraph, but you need to take all these points down so that you know what are you supposed to do. And then you are being told that to create a test class. So you need another class again for your 3 classes. So create a test class for your 3 classes. So in the test class, so you're going to have a test class, and then in the test class, you create a one object for grad and then another for undergrad, and then you test your methods. And only here method that we're talking about is passed, but you can have any other methods that you want, and then you test them. So for each object, provide a grade and display the result of is passed method. Just as simple as that, 20 marks. So what you are supposed to do, good. For this one, I already have the test class. Boom, 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 boom. So let me take everything out. Yes, you already have the test class with the main method. So guys, you are supposed to have this class lastly, the test class, and it's the one that we are going to use to test the 3 class that we have been given. And then remember guys, we are supposed to create a class called what? Student. So I just have to say class student, right? But remember guys, this class was said is going to be an abstract class, and we are going to see why is it going to be an abstract class. And then if you look at this, we are going to have a superclass called the student. Let's ignore the undergrad and all. The superclass student should have the following data members: name, ID. What do I want here? Right. Let me just have this. Guys, I need to have these things. Yes, I'm good at copying and pasting. So guys, these things are supposed to be inheritable. So let me just mark them. Public, string name. I can have public, string ID. You can put even in an integer there. Allow me to do this. All right. All right. Address. All right. No need of following the order there. Address. What else there? I need an int for age, right? Just as simple as this. This was the first requirement. This was the first requirement. This was the first requirement. And then you are being asked to have a Boolean method code is passed, right? A Boolean method code is passed. And it is being said that you need a method code is passed. And it is being said that later on, it is said that in the student class, this should be empty and abstract method. If you are looking at that, so it means that this method should be an abstract method, right? So I need to mark it abstract, and this is where all the problem starts. Why? Because I've put an abstract method here. It means that also I need to mark this class what? Abstract, which means this class must be also an abstract class. Then boom, all my problems are gone. So guys, this is the method that I'm being said to be an abstract method. Yes, it's abstract. Boolean is passed, and it's taking a double grade, and this grade is said to be between 0 and 100. So you need to check that as well. That is the number between 0 and 100, and then you can say that the grade is blah blah blah, something like that. So in the student class, this method should be empty. Yeah. So the 2 subclasses now that we want, which is the undergrad and the grad, right? So maybe you can declare them as well. You can have the class grad, right? But this class grad is extending or is inheriting from the what? From the class student. So you're going to have extends student. Guys, allow me to do what I'm used to do. Okay, because it's what let's ignore the issue. This issue is because we are inheriting this abstract method. It means that here we need to implement it. Otherwise, this one will be also a what? will be also an abstract class. So let's just ignore that. But allow me to do what we always do, copying and paste. And then this one is supposed to be under what? Undergrad. Right, is it undergrad? Yes, just like that. Okay, so after this, undergrad, just like this, we have these two classes. So what's next? So in the student class, okay, we inherit the data members class and override the method is passed. So we need to override the method is passed. So let's override that method. Allow me to do what you always do. Allow me to do what you always do. All right, so to implement the method, guys, very, very simple. Just need to override this method. You can type it on your own. I've just auto-generate it because I can do so. But this is what you want to do. But guys, when you're implementing, we are just returning false here because we've just generated them. But don't forget that this method needs to return a true or a false basing on the grade. So that's what you are supposed to do. You need to put a condition there. So this saying that for the undergrad class, now you are looking at the undergrad. Let me quickly go to undergrad here. Okay. So on undergrad class, for the undergrad class, if the grade is above 70, then is passed returns true, right? So we need to check if the grade is greater than 70, and then it will return true. So we are going to pass the grade, and then we are going to check if here, and then we return something, right? If here we return something else, we return something. Yes. So we want to put a condition. It was saying for the undergrad class, if grade is above 70, then it's passed, it returns true. Otherwise, it will returns false. So I want to check if grade is really greater than what? 70. Right? If grade is greater than 70, we return true. Otherwise, we return what? False, right? But the grade should be the grade should be what? Between 0 and 100. How can we enforce that the value between, it must be the value between 100 and, so maybe you can protect this code here. What can we do here? What can we do here? We need to check if you can even protect this. But the problem is that this value, okay, we can do this outside this. I am seeing the challenge because we are only returning true or false. So there is no other option. We cannot return something which is not that. So you can either return true or false. So maybe you can do that when you are calling this method. You need to make sure that grade is between that range 0 and 100. It was being said so. Yeah, it was being said so. Yeah, so we do not need to enforce it on this one. So for the grade class, the grade is above 80, then we say is passed, return true, otherwise returns false. So guys, here, let's just take this. Allow me to do what we always do in programming. We do copy and paste, or we do cut and pasting. And here we are saying if it's greater than 80, not greater than or equal to, I'm sure, but it's above 80, which means greater than 80. Then we can say that we return true, otherwise return false. What else am I supposed to do? So create a test class. Now I need a test class. Okay. So create a test class for your 3 classes. In the test class, create one grade object, and then undergrad object, test your method for each object, provide. Okay. So now I'm supposed to come to this test class, and in here, I'm supposed to create a grad object, grad. Maybe I say grad is equal to new grad. All right, let me just do the same for undergrad. You see the spirit of copying and pasting. Undergrad, under is equal to new undergrad. And just like this. And then what else? What else? It's now at 27 past 7. Okay. So what I'm supposed to do here is to test the method, which is this one. Guys, you can give the name. I'm just going to skip that. You can test the method. I can test the method. So guys, how can I do that? Maybe you can ask the person to enter the grade and then you check if it is between 0 and 100. And after that, you can print. What you just need is just to test the method. You are not forced to do so. You can also do so by just passing a specific value to what? To the grade, right? But I think it's wiser for you to do that because here we are supposed to check the purpose of the spasm is to take a parameter grade value between 0 and 100, right? So we need to make sure that the value is between 0 and 100. So maybe we can actually do that. So maybe I can have a simple local variable int grade there, and then maybe I can put 50 there. And then after that, what I'm going to do is I need to check if I want to test the method. I want to test the method, which is grade, and I'll print the output basing on that. It is going to return either true or a false. I want to test, it is going to return either true or a false. So it's what? In the test class, create one grad object and what test your methods. Okay, how am I going to test that one? Let me just make it simple. Sys out. All right. Let me just make it simple. Let me take grad and then dot is passed. All right, let me just, and then I'll just pass grade. Let me just make it simple. We will do the other things later. Let me just make what's primary there. I just want to test this method. It is going to give me false. Why? Because I have put 50, which is less than what? The grade, which is less than 70 there. I can, which is less than 80. Then I can do the same for under grad, right? And check under grad. I'm testing. What is it doing there? It's give me false, right? So after this, I've seen that it's working. I've seen that it's working. So maybe I can say if, right? I just want to enforce the range. If grade is greater than or equal to is equal to 0 and yes, grade is less than or equal to 0, then I can restrict all this code in here. All right. And also, guys, you can even check if grade is what, and you can print something interesting, right? You have passed, you have failed, something like that. You can do so. You can do so. It's very, very possible. Here it's because I have put what? Oh, sorry, here it's supposed to be not 0, it's 100. Sorry, it's 100. All right. Okay, I'm going to get a false. What if I put a 75? Let me put a 75. I'm going to get a false and a true, which means if it is 75 for undergrad, you behave what? Passed, but for what? For grad or for grad, you behave failed. It will be what? It will be false. So guys, here you can put an else. Maybe you can say invalid input or out of range. Sys out. Then you can say maybe out of range, something like that. So if I put maybe -20 or -30 there, I'll get out of range, something like that. So guys, I can even try to say here, so here I'm trying to be versatile, but otherwise it's just enough. Here you can even try to say if the grade, or if I say if, and then I'll pass this on, what happens? boom. I wasn't supposed to remove the. Then here I can say you have passed, otherwise you have failed, right? Here I can say cease out. Guys, you do not need to strain yourself up to this one. You have passed. Instead of just putting a true there, you have passed. Otherwise, else, system out, sources out. Then here we can say you have failed. Okay, let's see what could be the outcome. Is forward is for grad. Let me just put 70. Let me just put 82. So you are seeing that we are seeing you have passed. Instead of just seeing a true or a false, we are seeing a what you have passed. I know that here this method is actually returning what it's supposed to return. It was supposed to return either true or a false. So it is still returning a true or a false. So because it have returned the true, that's why I've got you have passed. If we put something less than that, let me put 75, it return that you have failed. So you are seeing that now here you have what? You have failed. So this is how you can attack this such type of what of questions. You need to go step by step. If you look at it, it's the whole paragraph. If you try to do it once, you're not going to win. You're not going to win. You need to go step by step, line by line, understanding what am I supposed to do, which concepts am I supposed to do. For this one, you're supposed to use the concept of what? Inheritance as well as abstraction. That's what we're required to use here.